All right, let's take a look at this next one. So we're solving for x in each of these, and we're finding the range of solutions for x which would make this equation true. These are quadratics in disguise, and so we'll kind of see that as we go along. So I've got 3.8. Let's do this one here. This is the last one in that section, which usually makes it one of the harder ones. So x to the power of a half, plus we've got 10x to the power of negative 1/2 is equal to 7. The negatives always, I think, cause a bit of rustling amongst the troops. So let's see how this plays out. So lots of ways of doing this. I'm actually going to, what am I going to do? I'm going to turn this actually into kind of third form for a moment. So this is really root x plus, this is 10x over, this is actually 10, sorry, over root x is equal to 7, yeah? So I can see we're going to end up in quite a different place, actually. Now, the first thing I want to do, I want to get rid of the half there. And I could have done this a number of ways. I could have just multiplied everything by x to the half, and that would have done it. I'm going to do it differently, though. I'm going to just multiply everything by root x. Because if I multiply this thing here, so I'll go, that implies that. If I've got root x here, so if I've got root x, and I've got plus 10 over root x is equal to 7, and I multiply this by root x times root x, and I multiply this by root x, and this by, of course, root x. I've got root x times root x, which turns into x. This implies that x plus, well, root x divided by root x is 1, and that leaves me with 1 times 10, which is 10, is equal to 7 root x. All right. Now, I don't really want square root of x's. I want something else, something easier. I would be really happy with if these were all, for example, x's. But they're not. So I'm going to take the root x, and I'm going to make that y. So I'm going to say, let y is equal to root x. And of course, that would mean root x times root x would be y squared. So therefore, y is equal to x, because root x times root x is x. Sorry, what did I say then? Did I say equals x squared? Okay, let's say it again. Make sure I'm clear on this. So if y is root x, then y squared must be root x times root x, which is just x, because root x times root x is just x. So, sorry, I don't know if I misspoke, then I can't remember. All right, let's try this. So now let's restate this equation in terms of y instead of x. So in other words, here's an x, and I know that x is equal to y squared, so that implies that y squared plus 10 is equal to 7 lots of, well, instead of a root x, well, I know that root x is equal to y, so I'll go 7y. Now, I want this to equal 0, so I'm going to subtract 7y from both sides. There it is, subtract 7y. This now becomes a 0. So now that implies that I've got a y squared minus 7y plus 10 is equal to 0. All right, so a little sidebar over here. Well, I've got factors of 10. Well, I know factors of 10 are going to be 1 and 10 and 2 and 5. And that's all we've got, but that's all we need, because I'm going to factorize this now. I've got a y and I've got a y. Signs are the same, both negative. There they are. And I've got a 2 and a 5. And 2 and a 5, well, 2 times 5 is 10, and 2 and 5, which are both negative, is negative 7. So that works out well. So either we can say y minus 2 is 0. So therefore, either y is equal to 2, or I've got y minus 5 is 0, so y must equal 5. So I'm going to test these two things here. And of course, it's not really y equals 2 or y equals 5 we're interested in. We're interested in what y is. Well, y is root x. It's really root x is equal to this and this. Well, let's test those things now, yeah? Because we know that y is equal to root x. So therefore, we can say we've got root x is equal to 2, which, of course, if root x is equal to 2, and I was to square both of those, square that and square this, then x must equal 4. Or the other side of that would be root x is equal to 5. And of course, if I was to square both of those, square this and square this, we'd find that x was equal to 25. Okay, so we want to go back to the original now equation and test both of those ideas. So let's try that now. So I'm going to go, we've got x, and I'll go back to the original. Here it is, x to the power of a half. And in fact, I'm actually going to write it like this. I think that's going to be more useful to test. I don't like powers of negative a half and things. So I've got, here's my original. I've got root x plus 10 over root x equals 7. Is that true for both of these? Well, let's try this one first. So I put let x equal 4. So I got root 4 plus 10 over root 4. Does that equal 7? Well, root 4 is 2. Root 4 is 2. 10 over 2 is 5 equals 7. Yes, it's true. Therefore, we can say, therefore, x equals 4 is a valid solution. So this is true, yes? So x is 4 is a valid solution. All right, let's try the other one, which was root x over 10, and we're going to try x is 25. So we're going to say 25 plus 10 over root 25 is equal to 7. Is that true? Well, root 25 is 5 plus 10 over 5 is 2 equals 7. So therefore, yes, it is true. That does work. So we're going to say x equals 25 is a valid solution. So now we've got two valid solutions. X is 4 is true, and x is 25 works just as well. All right, so that's how we got from the original place, which was over here. Still have the negatives and things in there, but that's how I get my answer. Hope that makes sense.